The exercise related to space physics, we are done with the first 16 questions. So we'll start with, like today, we'll do questions 17 and 18. You can use your mic or a chat to participate. Question 17, it's about the Hertzsprung-Russell diagram, shows how different astronomical objects may be classified according to their color and the absolute magnitude. So basically, this whole region is the main sequence star. What are the main sequence stars? Main sequence stars, because for stars, two things happen. One is a radiation pressure, which is outward, and another one is a gravitational pull, which is inward. So when the radiation pressure, the outward pressure balances with the gravitational pull, that type of a star or that phase of a star is known as the main sequence star. Yeah, stable stars like our sun is a main sequence star because the radiation pressure is balanced with a gravitational pull. But if the radiation pressure is high, as a result, like if greater rate of fusion, then the size of the star increases, and then it becomes a giant, or we can also say a red giant. So in a red giant, the radiation pressure is more, like the star, it turned from main sequence to red giant when the radiation pressure is more than the radiation pressure is more than the gravitational pull. And then when the radiation pressure is less and the gravitational pull is more, the star will turn into a white dwarf. And in a white dwarf, what happened? Like almost, it's like a dense, very high temperature, dense, having a smaller mass, a smaller size as compared to other stars. So the question is, the diagram shows 3 stages of evolution of the star of a similar mass to the sun. So basically, this is like a sun-like star because we have a massive star. If we have a massive star, it will have a different cycle. So we have different star cycles are there. Low mass star follow different star cycle as compared to a high mass star. So what we have to do in the question, describe the evolution of a star of similar mass as sun. Your reference should, you should refer to a temperature and the brightness of a star in your answer. So if I show the star cycles, like just a quick recap, what we have discussed about the star cycles, that there are 2 ways the star can proceed, like the cycle of a star. One is a sun-like star. Another one is the massive star, like the stars which have size more than like eight solar masses. So you can see here, this is a star cycle. So first, what we have a protostar. Then if we have a sun-like star is there, then it will be a main sequence star. And it will remain in a main sequence for a longer period of time. Then it turned into a red giant. And that due to a planetary nebula, what we are left with a white dwarf. Whereas if we have a high mass star, it will turn into a blue supergiant, you can also say, or a red blue giant or red supergiant. And then a supernova, which leads to formation of a black hole and a neutron star. So this is what happened. Like a quick recap, what we have discussed about. So star, it always start with a interstellar clouds. Interstellar cloud, mainly it contain like rocks, it contain the gases. And due to the gravitational pull, the cloud will contract and slowly get enough dense, and it will form a protostar. So first thing what happened, the interstellar cloud, the particles come closer and gravity pull them together and it will form a protostar. And eventually what will happen, because as the particles come closer to each other, so potential energy increase, the kinetic energy decrease, potential energy decreases, kinetic increase, so they will have more often collision. As a result, the temperature increases and a fusion of a hydrogen start. And this release the energy and create enough pressure to stop the gravitational collapse. And we call the main sequence star. So our sun is actually right in this phase of a main sequence. When all of the hydrogen fuse ceases, as a result, the outward pressure will fall because the radiation pressure decrease. So star will start to contract, and this second contraction leads to a helium fusion. That will heat up and it start a helium fusion. When helium fusion start, the radiation pressure is more than the gravitational pull. So size of the star will also increase, then it will become a red giant. So our sun will turn into a red giant and its size will increase. And eventually what will happen? When the helium fusion ceases, the outward pressure no longer balance with the gravitational collapse, the gravitational pull, and the temperature of a star during this contraction won't rise enough to start like fusion of the heavy element. So as a result, the outer layer of a star become unstable and ejected into the space, which will as a planetary nebula, and core remain as a white dwarf. So what actually happened here, we have a protostar, like from interstellar cloud. Then from a protostar, we have a main sequence star like sun-like star. The gravitational force balances with the radiation pressure. Then once all the hydrogen fusion or mostly hydrogen fusion cease, then it will start a helium fusion. And why it will start a helium fusion? Because gravity will, like gravitational collapse or the attraction towards the center. So it will turn into a red giant. And from red giant, what will happen when all the helium fusion ceases or helium fusion decreases? So now again the gravitational collapse is there, but this time the gravitational collapse is not able to start up, like the temperature does not increase too much to start the fusion of the heavy element. As a result, the most of the substances which are left as an interstellar cloud or a nebula, and at the center what we have a white dwarf. So we have to write the points here about the star. So if we have a sun-like star or a main sequence star, it will turn into a red giant, and from red giant, it will turn into white dwarf and the planetary nebula and result in a formation of the white dwarf. So the points you will mention how the sun, like basically it's like a star cycle of a sun, and likely this question you may find in the exam as well, more likely this question. So planetary nebula is basically a phase in the cycle of the star in which it's not able to hold the outer part. Most of the outer part is released to the surrounding, and only the central core is left as a white dwarf. And actually a death of one star is like a birth of another star. When one of the star is dying, the another star will born. Like this planetary nebula here, this planetary nebula, what it produce also like different elements are there this region. So this again combine together, and then how much solar mass is there, then it start another cycle. So that's why we call this as a star cycle. Like it's a continuous process. Like when one star is dying, the other star will born. So the points we will include, the first one, so interstellar cloud. Form protostar. Yeah, supernova is like an explosion. It's happened for the high mass stars. So first, what will happen? The interstellar cloud is there, which mainly consists of different gases as well as the rocks. As a result of this, when these particles come closer to each other, so the gravity, like it's pulling all the particles together, the temperature increases, which start the hydrogen fusion. And for a start, the fusion happened, like the main source of production of energy is a fusion, nuclear fusion. So the temperature increase which start the hydrogen fusion. As a result, what will happen when the radiation pressure balance with gravitational force or gravitational collapse? Star is in main sequence, or we call that a star as a main sequence star. How the temperature of a star is increasing? Because first, like this is representing an interstellar cloud. When these, due to the gravity, when these particles are coming close to each other, so there's a decrease in potential energy. If the potential energy decrease, the kinetic energy will increase. And as the kinetic energy increase, the kinetic energy and temperature are directly proportional. That's why the temperature of the star increases. Then what will happen when hydrogen runs out? The main sequence star become the main sequence star turn to red giant because of helium fusion. So then the helium fusion start, and then the star size also increases, like the radiation pressure will be higher than the gravitational pull. And eventually what will happen? The red giant turn into white dwarf, or red giant, the phase will be planetary nebula, which result in a formation of a white dwarf. So when helium fusion ceases, the star will change to, or when the helium fusion stops, the star will turn to white dwarf. I'm writing in short, but you can write the whole cycle of a star. Like these are the points you should mention about the star cycle. This whole points are there. It's better you memorize these points, learn these points, and write as it is stated. Is it clear, the star cycle?
Yes, clear.
The next question, question 18, you can use your mic or a chat to state the answer. The first one is, which force is responsible for keeping a satellite in orbits? Which force is responsible for keeping the satellites in an orbit? So the gravitational force or a gravitational force. The next one, which of these, these is the largest? A galaxy, planet, star, universe. Then which of these represent the brightness of a star? Which of these represent the brightness of a star is refers to as an absolute magnitude. The absolute magnitude, when we say absolute magnitude, it refers to a, like it's a comparison. But when we compare the brightness of a sun with other substances, we call that, or other astronomical objects, we call that as a absolute magnitude. Basically, if you see this one, like what will be the position? This is a comparison. When we compare them, like when we are comparing, like the absolute magnitude is there 15, 10, 5, 0, and -5. So this actually refers to the brightness of a star. Higher absolute magnitude, like in a more negative, means it is much brighter. More positive, it means less, like because it's a comparison. Like when we say +10, what does it mean? Like compared to, like sun is 10 times brighter than this white dwarf. That is the meaning. The absolute magnitude is a comparison of how much the star is brighter. So if we have on a lower scale, this is, and these are the colors like blue, white, yellow, red are there. So what is representing an absolute? It's a comparison with the sun. So why, like when we compare sun with a white dwarf, like sun are like 10 times much brighter than a white dwarf. Is it clear about this idea? So it's a comparison, comparative property. So absolute magnitude is normally represent the brightness of a star as a standard distance. Means -5 is representing like comparison that it is less bright, sun is less brighter compared to that part. This is all are compared with the sun. -5, +10, +15, these are all comparative properties. So when we compare the brightness with the distance, that is in a standard, like we consider all, if all of them are at the same distance and we compare their brightness. So this is actually representing the absolute magnitude.